Imagine a world where Galileo Galilei was never condemned by the Catholic Church, a world where his revolutionary ideas about the cosmos were freely explored rather than suppressed. In this alternate timeline, humanity reaches the moon centuries earlier. Technology advances at an unprecedented pace, and the relationship between science and religion evolves in harmony rather than conflict. But to understand how we might have reached this different future, we must first examine the pivotal moment when science faced the judgment of faith. If you're enjoying what we're creating, please consider hitting the like button and subscribing. It helps us out more than you can possibly imagine. In the early 17th century, Europe was a continent where faith and authority reigned supreme. The Catholic Church held enormous power over intellectual discourse, and challenging its teachings was not merely controversial, it was dangerous. Enter Galileo Galilei, an Italian astronomer, physicist, and polymath whose observations through his improved telescope would shake the very foundations of medieval cosmology. In 1610, Galileo published Sidereus Nuncius, or The Starry Messenger, detailing his discoveries of Jupiter's moons, lunar craters, and countless stars invisible to the naked eye. These observations provided compelling evidence for the Copernican heliocentric model that the Earth and other planets revolve around the Sun. But this challenged the Church's geocentric doctrine, rooted in ancient Greek philosophy and biblical interpretation. According to the accepted worldview, Earth was the immovable center of God's creation, with all celestial bodies revolving around it. To suggest otherwise was to question both scientific and theological authority. In 1616, the Church formally condemned heliocentrism as foolish and absurd in philosophy, and formally heretical, since it explicitly contradicts in many places the sense of Holy Scripture. Galileo was warned not to teach or defend the theory, yet he persisted. In 1632, he published Dialogue Concerning the Two Chief World Systems, a masterful work that presented arguments for both geocentrism and heliocentrism. Though ostensibly neutral, the dialogue clearly favored the Copernican system, with the geocentric advocate portrayed as foolish and the heliocentric proponent as wise. This literary masterpiece sealed Galileo's fate. In 1633, at age 69, he was summoned to Rome to stand trial before the Roman Inquisition. The charges were grave: suspicion of heresy for defending the proposition that the sun is the center of the universe and immovable. The trial revealed the deep tension between emerging scientific methodology and established religious doctrine. Galileo's insistence on empirical observation and mathematical proof clashed with the Church's reliance on scriptural interpretation and Aristotelian philosophy. His famous declaration, "Eppur si muove," or "and yet it moves," captured the irrepressible nature of scientific truth. Found guilty, Galileo was forced to publicly recant his beliefs and spent the remainder of his life under house arrest. His scientific works were banned, and his voice was silenced by the very institution that claimed to seek truth. This moment marked more than the persecution of one man. It represented the collision of two worldviews: faith-based authority versus evidence-based inquiry. The trial became a symbol of the broader struggle between scientific progress and institutional resistance to change. But what if history had unfolded differently? What if Galileo had never faced condemnation? What if his ideas had been allowed to flourish without persecution? In this alternate timeline, Galileo's continued work would have provided even more compelling evidence for heliocentrism. His telescopic observations were just the beginning. With institutional support rather than suppression, he could have established a research center dedicated to astronomical observation and mathematical analysis. This would have accelerated the acceptance of the heliocentric model throughout Europe. Other scientists, inspired by Galileo's freedom to pursue truth, would have built upon his work without fear of persecution. Johannes Kepler's laws of planetary motion would have gained immediate acceptance. The scientific method, observation, hypothesis, experimentation, and peer review would have become the standard approach to understanding the natural world. Without the chilling effect of Galileo's trial, the scientific revolution would have gained momentum decades earlier. Isaac Newton, born just a year after Galileo's death, might have developed his theories of gravity and motion in an environment that celebrated rather than feared scientific inquiry. His work could have emerged in the late 17th century instead of the early 18th. This acceleration would have profound implications for technology. With a deeper understanding of physics and astronomy, humanity might have developed advanced telescopes, precise navigation instruments, and mechanical devices centuries ahead of our timeline. The Industrial Revolution could have begun in the 17th rather than the 18th century. Perhaps most dramatically, space exploration might have begun centuries earlier. With Newton's laws established and refined through continuous research, humanity could have launched the first artificial satellites in the 18th century. By the 19th century, we might have established lunar colonies. The 20th century could have seen missions to Mars and beyond. The relationship between science and religion would have evolved differently as well. Without the Galileo affair as a cautionary tale, religious institutions might have embraced scientific discovery as a means of understanding God's creation. Rather than viewing science as a threat, faith communities could have seen it as a partner in exploring the wonders of the universe. This collaboration might have prevented the long-standing conflict between science and religion that has characterized much of our history. Scientific advances would have been celebrated by people of faith, and religious insights might have informed ethical considerations in scientific research. The implications extend beyond technology and religion. In a world where scientific inquiry was encouraged rather than suppressed, democratic ideals might have emerged earlier. The same spirit of questioning authority that drove scientific revolution could have challenged political absolutism. The Enlightenment, with its emphasis on reason and individual rights, might have begun a century earlier. Education systems would have prioritized critical thinking and empirical investigation. Universities would have become centers of innovation rather than bastions of traditional doctrine. This could have led to earlier development of the scientific method as a standard educational approach. Even our understanding of humanity's place in the universe would be different. Rather than feeling diminished by the realization that Earth is not the center of everything, people in this alternate timeline might have felt elevated by their ability to understand and explore the vast cosmos. The trial of Galileo Galilei represents a pivotal moment when the advancement of human knowledge was temporarily halted by institutional fear. But in imagining a world where this didn't happen, we can appreciate how different our reality might be. While we cannot change the past, we can learn from it. The story of Galileo reminds us of the importance of protecting intellectual freedom and encouraging scientific inquiry. It shows us that progress often requires the courage to challenge established beliefs and the wisdom to embrace uncomfortable truths. Today, as we face new scientific frontiers and ethical dilemmas, we must remember that the pursuit of knowledge should never be imprisoned by fear or dogma. The universe is vast and full of wonders waiting to be discovered. Wonders that can only be revealed when we have the freedom to ask questions and seek answers wherever they may lead. In the end, Galileo's greatest legacy may not be his telescopic discoveries or his defense of heliocentrism, but his demonstration that truth, once glimpsed, cannot be permanently suppressed. The Earth does move around the sun, and human curiosity will always find ways to uncover the secrets of our cosmos. Thanks for listening to History Rewritten. Join us next time as we explore another pivotal moment in history and imagine how different our world might be